So in this video, we're going to talk about rotations in the coordinate plane. Unlike reflections and translations, we actually have some formulas that we need to memorize in order to use. But before we do that, let's talk about what the possible rotations could be. I decided to use a smiley face as our pre-image as opposed to a geometric figure so you can kind of see what's happening in the picture. We have three main types of rotations that can happen from the pre-image. We have a 90 degrees counterclockwise, which is to the left, 180 degrees. Notice I didn't say clockwise or counterclockwise because it really doesn't matter. It ends up the same way. And 90 degrees clockwise to the right. Notice that the figures are actually they're moving to the quadrant that is in that direction. So the 90 degrees counterclockwise, which goes to the left, is just one quadrant over. If you notice what the counterclockwise has, you notice that it's turned on its side. I consider this a quarter turn. It hasn't turned all the way around, it's not upside down, it's not a full turn. Now 180 is a half turn because we can see that the little smiley face is upside down. Now a full turn is 360 degrees, but typically we don't see any of those on an exam. Pause the video for just a second and please write down these rotation rules. Like I said earlier, rotations don't have little tricks that we can use on the graph. You have to use the rotation rule. The three rotation rules that we have are down below. Now, I'm just going to share with you what a lot of my students have used in the past as ways to remember these rules. Since 90 degrees clockwise is not a halfway turn, that means that it's a quarter turn. The points are switched. They've been turned. When I turn clockwise, that's turning to the right, so the right coordinate is negative. We're going to practice some numbers in just a second to make sure you understand. The next one, which is counterclockwise, has a similar feel. It's another quarter turn, so we flip-flop the x and the y, and because it's counterclockwise, that means it's to the left, so the left-ordered pair shows. When I showed you 180 with the smiley face was upside down. It was the complete opposite of what it was before. Therefore, the points are the complete opposite as they were before. Before we look at a graph, I'd like to make sure we try some points just to make sure you're okay. So if our ordered pair for our pre-image is -5, -3, how would our points change? Well, for 180 degrees, we know that the points stay the same except they become the opposite. So instead of -5, -3, they're now just +5, +3. When I have points that are counterclockwise, it's a quarter turn, so we turn the points. And if it's counterclockwise, that's to the left, so the point on the left will change. 90 degrees clockwise is similar, but now we're turning to the right. So we still turn the points, but it's the right point that is now affected. Don't worry if you don't have this down perfect through the video. It's important to really understand the rules in the video. We will apply them in class tomorrow. Here's our first example. We're going to rotate this triangle, ABC, 90 degrees clockwise. Clockwise means I'm going to take this triangle here and it's going to turn a quarter of a turn to the right. But we need to understand where will those points actually exactly be. So it's a quarter turn, so we turn the points. It's to the right, so the right point changes. So the point 0.12 becomes 0.2-1. Pause the video and see if you can predict what B prime, or the image of B, and C prime, the image of C, would be. B prime's point would be 6, -1, and C prime's point would be 2, -8. So our triangle, we want to make sure we align it where it belongs. So 2, -1, 6, -1, 2, -8. It's in the correct place. So that's all that we have to do, and we can check that our answer is correct because I can tell the triangle was turned a quarter to the right. Now for my favorite transformation, which is the 180 degrees. They're the easiest points to find. It's the same triangle we had before, just for ease of writing down notes. So remember, 180 means opposite, So that means point A is -1, -2. Pause the video, see if you can find the other two missing points. Point B prime is -2, -6, and point C prime is -8, -2. Since all these points were originally all positive, they're going to be all negative in this case. 180 means that it's upside down, so that means now my points are at -1, -2. And if you look here, they almost look like they're reflections of each other, but there is a slight turn. A lot of my geometry kids notice that a rotation that's 180 degrees is a double reflection. It's a reflection over the x and a reflection over the y. Now for this last question, I want you to try the problem on your own. In about 20 seconds, I'm going to reveal the answer, so be sure to pause the video and see if you can find it. So on your graph, you want to draw the triangle that's stated there. And sometimes books say 90 degrees about the origin. That's another word for just counterclockwise. So again, in about 10-15 seconds, I'm going to show you what the new points are. So the new points I have down here. I have my rule up here so we can see what it is that we needed to do. So we had to turn the points. Because it's counterclockwise, all the points on the left changed. So now that I have my new points, I should have something like this. This image here in green is what we have transformed or rotated around the axis.